Hi everybody, welcome to Dr. Manny's YouTube Learn Shops. This is part 2 to Descriptive Statistics, which deals with probability. The learning objectives for this session are basically just to understand probability as a measure of uncertainty. When we look at descriptive statistics, just to recap, descriptive statistics describe, present, summarize and organize data either through numerical calculations or graphs or tables. Descriptive statistical analysis helps you as a researcher understand data. And doing descriptive statistical analysis of the data set is crucial. Numerous researchers omit this part and therefore lose valuable insights about their data, which often leads to wrong conclusions. Misuse. Probability, let's preview it. As a measure of uncertainty. Everywhere we are surrounded by uncertainty. If you think about it, there are many things that we're unsure about. For example, what will the temperature be next Monday? How many inches of rain will we get in January? What will be your final grade in this class? Will you be living in the same place in 10 years? Who will win the election in 2025? Will you get married before you're 30 years old? Is there life on Mars? There's a lot of uncertainty. So probability in statistics is simply a number between 0 and 1 that measures uncertainty of a particular event. Although many events are uncertain, we possess different degrees of belief about the truth of a certain event. For example, most of us are pretty certain of the statement, the sun will rise tomorrow, and pretty sure of the statement that the moon is made of green cheese being a false statement. We can think of probability as a scale from 0 to 1. 1 is a sure event will occur. 0, it's a sure event will not occur. Somewhere in between, the event and non-event are equally likely. So consider, as we said, most people would give the statement the sun will rise tomorrow a probability close to 1. The statement the moon is made of green cheese a probability close to 0. It is harder to assign probabilities to certain events that have probabilities between 0 and 1. Let's review. For each of the following questions, state the probability value. Think why you gave this particular probability value, I guess. Suppose you had a bag with 2 white and 4 red balls. You choose a ball at random from the bag. What's the probability that the ball you chose is white? Suppose you walk into your college cafeteria blindfolded and bump into a fellow student. What's the probability the student is female? Suppose you toss a coin 20 times and get 19 heads. What's the chance or probability that the next toss is going to be heads? If you roll 2 dice, what's the chance or probability that the sum of the 2 dice rolls is equal to 5? When a meteorologist reports that there's a 50% chance of rain tomorrow, what does that actually mean? What is the probability that 2 people in a class have the same birthday, including month and day? Okay, let's reflect. After reviewing this activity, you should realize that probabilities are hard to measure. But there are several ways of thinking about probabilities, and these include the classical and subjective viewpoints that may be helpful. So, objective probability refers to a repetitive process, one which generates outcomes which are not identical and not individually predictable with certainty, but which may be described in terms of relative frequencies. These processes are called chance, and the results of the processes are called events. Subjective measures the strengths of personal beliefs. For example, the probability that prescribed medication will be effective. You believe that it will be. It's your subjective version. Probability terms can include the following. Experiment. An experiment could be something like whether it rains in Melbourne on a daily basis or not. The outcome is the result of a single trial. If it rains today, the outcome of today's trial is it rained. An event is one or more outcomes of an experiment. For the experiment of whether it rains in Melbourne every day, the event could be it rained or it didn't rain. The probability, this is simply the likelihood of an event, so there's a 50% chance of it raining today and a probability of 0.5. This is the classical review of probability. Suppose that we observe some phenomena, for example, the rolls of 2 dice where the outcome is random. You don't know what it's going to be. Suppose we write down the list of all the possible outcomes and we believe that each outcome in the list has the same probability. Then the probability for each outcome will be the following formula. P is equal to 1 over the number of outcomes. A simple illustration of classical probability is, suppose you've got a bowl with 4 white and 2 red balls. You draw 2 balls from a bowl at random. You don't place a ball back in the bowl after it's been selected. What are the possible outcomes? Outcome number 1, white and red ball. Outcome number 2, 2 white balls. Outcome number 3, 2 red balls. If we don't distinguish between the balls of the same colour, then there are 3 possible outcomes. Essentially, we choose 0 red, 1 red, or 2 red balls. Possibility 2. If we do distinguish between the balls of the same colour, we number the balls in the bowl. Then we can write down 15 distinct outcomes of the experiment of choosing the 2 balls. The frequency view of probability, which was developed by Richard von Mises in his Probability, Statistics and Truth book in 1928, was that the probability of an event in a situation can be defined in terms of the frequency of the occurrence of events of the same kind in some hypothetical population of repetitions of the same, and can be used in cases where outcomes are equally likely or not equally likely. This view of probability is appropriate in a situation where we repeat the random experiment many times under the same conditions. Another simple illustration is frequency view of probability. Suppose you're playing the popular game of Monopoly, which I play with my daughter, and we land in jail. We get out of jail on the next term in Monopoly. However, we either have to pay $50 or roll a doubles when we roll 2 fair dice. Doubles means that the faces on the 2 dice are the same. If we think that it is relatively likely to roll doubles, then we say, let's roll the dice instead of paying $50 to get out of jail. What's the probability of rolling doubles when you roll 2 dice? The frequency view of probability is each time we roll, we observe if we get doubles or not. The probability of doubles can be approximated by the relative frequency. For each experiment, we record if there's a match or no match in the 2 numbers that are rolled. For example, in these 10 experiments, they obtained a match doubles exactly 2 times. They're boxed, the outcomes. So the probability match is approximately 2 for 10. 10 attempts, 2 successes, 0.2, 20%. So in summary, the classical view is a way of thinking about probabilities when one can list all possible outcomes in such a way that outcomes are equally likely. The frequency view is when you can repeat a random experiment many times under similar conditions. You can approximate a probability of an event by the relative frequency that the event occurs. But consider, what if you can't apply these views of probability? What if the outcomes of the experiment are equally likely, or not equally likely, I should say, and it's not feasible or possible to repeat the experiment many times under similar conditions? Now let's look at the subjective view of probability. It's your belief. In this case, we rely on a third view, and this view is arguably the most general way of thinking about probability, since it can be used in a variety of situations. For example, your basketball team will win the NBA title next season. You can't use the classical or frequency views to compute this probability. Why? Because there are 8 teams in the NBA. Each team is a possible winner of the NBA, but these teams are not equally likely to win, as some teams are stronger than others. So the classical approach won't help in obtaining this probability. The event of your team winning next year is essentially a one-time event. Your team will have the opportunity to win the NBA in the future years, but the players on your team and their opponents will change. So it won't be the same NBA. So you can't repeat this experiment under similar conditions, different players. So the frequency view is not helpful in this case. There are 2 ways of looking at subjective probability. First, it's a personal belief about your team winning the NBA, which is different from my belief since we have different information. Perhaps consider you know very little about the teams and I'm very knowledgeable about the NBA basketball. That means that our knowledge will be different, and so our probabilities would also be different. 2, it also depends on the current knowledge about the event. Maybe you think that the probability is 0.70% since your NBA team was excellent last year, but when you learn that many of the star players from the last season have been transferred or retired, this changes your knowledge about the team, and you may now assign the probability a smaller number. So in summary, there are 3 different ways of thinking about probabilities: the classical viewpoint, the frequency viewpoint, and the subjective viewpoint. The classical viewpoint allows one to compute probabilities based on the structure of the problem. To apply this viewpoint, it's convenient to write down a collection of possible outcomes in such a way that each outcome is equally likely to occur. The frequency point uses a situation where one can repeat the random experiment many times under identical conditions. The subjective viewpoint is helpful in the situation where one expresses his or her opinion about the likelihood of a one-time event. So, definition for probability, there are rules. You can have mutually exclusive, conditional probability, and complement. So mutually exclusive basically means there are 2 events that can't occur at the same time. For example, a mutually exclusive event is a coin toss. A coin tossed outcome can either be heads or tails, but both outcomes are not possible. They can't occur simultaneously. Conditional is the probability that an event A occurs given that event B has already occurred. For example, event A is that it is raining outside and was a chance of raining today. Event B means that you may need to go outside, and that has a probability of 50%. Complement is the event that not occurring. Probability that events A and B both occur is the probability of the intersection of A and B. Example, the probability that a horse will lose a race. If A is the horse winning the race, then the complement of B is the horse losing the race. Additional probability rules are a dependent event. And this is when there are 2 events are dependent. The occurrence of one event influences the probability of another event. So for example, robbing a bank and going to jail. Not paying utilities bill on time and having your power or water cut off. When the occurrence of event A changes the probability of event B. An independent event are events whose occurrence are not dependent on each other. So for example, if we toss a coin in the air and get heads, then if we toss the coin again, but this time we get tails, in both cases the occurrence of both events are independent of each other. This means that when the occurrence of event A does not change the probability of event B. Additional probability rules. The union of two sets is a new set that contains all the elements that are in at least one of the two sets. The union is written as the following: A or B. Intersection. The intersection of two sets, A and B, is denoted by the following formula and consists of all the elements that are in both A and B. An example is A, the union, B equals AB. There are three main rules associated with the basic probability, and that's the addition rule of probability, the multiplication rule of probability, and the complement rule. And you can think of the complement rule as subtraction, if it helps you remember it. The addition rule of probability is basically in the following formula. If A and B are mutually exclusive events, or those that cannot occur together, then the third term is 0. And the rule reduces the formula to the following. For example, you can't flip a coin and have it come up both heads and tails in one toss. Not simultaneously. Then you've got the multiplication rule of probability. If A and B are independent events, we can reduce the formula to the following. And the term independent refers to any event whose outcome is not affected by the outcome of another event. For example, if you consider the second of two coin tosses, which still has a 50% probability of landing on heads, regardless of the first toss, what's the probability that during the two coin tosses you come up with tails on the first flip and heads on the second? This can be calculated. Now the complementary rule of probability, this rule builds upon the mutually exclusive nature of the following formula: P, A, and P, A naught. These two events can never occur together, but one of them always has to occur. Therefore, PA plus PA naught equals 1. For example, if the weatherman says there's a 0.3% chance, 30% chance of rain tomorrow, what are the chances of no rain? This can be calculated as well. Subtraction. So in summary, uncertainty is defined as doubt. When the economy is going bad and causing everyone to worry about what will happen next, this is an example of uncertainty. Probability answers questions about what will happen. Statistic answers questions about what did happen. Probability is about quantifying uncertainty, whereas statistics is explaining the variation in some measure of interest that we observe in the real world. Okay, that concludes this session in an introduction to the basics. There are 7 other parts to this basic statistics learn shop. And remember, it is just the basics. And you can get access to a lot of other information on some of the excellent YouTube videos. See you in the next session. And if you think this has been of any value to you, or any of the other Dr. Manny Learn shops, recommend them to your friends and colleagues. Thanks. See you soon.